Hello, this is the Tepid Coder. This time I'm going to talk about, let's see, I think I want to talk about arrays, pointers, and structures. We'll see how far into that I get. So, this is assuming you've watched my earlier video about primitives. Do standard types H. Okay. Function returns nothing. Oh, we're okay. Think about this for a second. So, earlier I discussed types like char. You have char c, which equals like a, right? It's character a. We also had things like to be char t, which could hold like a wide character a, which is kind of equal to, imagine you have t, let's say, it'd be equal to 2. Yeah, the a comma 0, like that. Anyway, what I want to talk about now is actually arrays. So you can have more than one of these. So if you don't put anything in the brackets, you can give it any number of items to start with. So this could be 1, 2, 3, you know, it could be A, B, C. I could also just use a string here, right? And say this is only a test. So however long this is, it'll automatically make an array that size. Keep in mind, though, that if you see quotation marks in C or C++, it automatically adds a 0 terminator at the end. So whatever the number of characters is in the string, it's that plus 1. And if it's a wide character, so wchar t, and say it's like wc for wide character, and you did this is only a test. In this case, each one of these characters is 2 bytes. And then the 0 at the end is also going to be 2 bytes long. So this is going to be literally double the size of this string and double 0 at the end. Okay, what can I say? When you're accessing a member of an array, first of all, I'm going to print this out so you can see how it works. So, since ins formats a string, the string I'm giving it, I'm not going to call it C, let's just call it C-A-R-Y for C array. I'm going to compile that first to show it. Anyway, you can see it prints out that string. But if you want to mess with one of the values in an array, kind of like I showed in one of my earlier videos with the assembly language, I incremented the first character. I could do the same thing here and say C array position 0 plus plus, or plus equals 1 if you prefer. I don't think I actually mentioned that in the video about arithmetic operations. If you have some variable like int I equals 0, you can do I++. That'll make it so it's now 1. That'd be the same thing as I plus equals 1. But you can also do plus plus I. This does the same thing, but there's a slight difference. So see, I have int x here. If I say int x equals I++, it's going to say x equals whatever I is at the current time, which is 0, and then it's going to increment I. So I becomes 2, x is still 0. But if I did this, x equals plus plus I, it's going to say x equals whatever this is going to become. So if it's 0 right now, it's going to become 1, so x becomes 1. So x and I are both 1 in this case. Anyway, that's something I forgot to mention. Anyway, in this case, we're talking about arrays, and arrays start at index 0. The reason for that is you imagine, like, this right here represents the address in memory of this whole string. And if I want to mess with the first character, I don't want to move away from that. I want to start right where I already am. So I'm going to move away 0 bytes from the start of this block of memory. I'm going to add 1 to it. If I did 1 here, it's going to actually increase to the next character in memory, because that's the type, is character. If the type were something else, like say the type were uint32t, uint32 array, you know, something, let's say it's got 3 elements, right? 0, 1, 2. Now if I did this, UI32 array something, position 1, that's actually going to make it so that wherever this is in memory, it's going to add the size of a uint32t, which is 4 bytes, times 1. It's that far away. So it's going to jump 4 bytes ahead and assign that value to 10. So it'd be 0, 10, 2 in this case. Anyway, let's run this code here so you can see that I've manipulated the first character of the string. There it is. It still says this is only a test, even though I wrote sys is only a test. And this will work for any type. You can even have structures. And that's what I'm going to show next. So let's get rid of that for now. If you want to have a bunch of related data stored in one variable, that's when you would collect the data into a structure. So the way you do that is you say struct, define a structure, and you give it a name. So I'm going to say, how about record? And this is going to be some kind of record like in a database. Let's say it's got some address, it's got a phone number, and a person's name. So let's say we have a character array. We'll call it name. Actually, we'll call it SZ name. I like that better. And I'm going to say, hey, the person's name can be 20 characters long. Why not? I'm going to say, let's see, address. Address can be a lot longer. Let's say it can be 100 characters long. Whatever. And then character to see phone number equals, what can a phone number be? 10? 10 characters? Let's see. 23-ish. 23-24. In fact, I would do it this way. So how many is that? Got 1, got 3, got 3. So what are we up to? 7 plus 4 is going to be 11 plus that dash is going to be 12. So I need 12 characters for that. Maybe I want to space it out more nicely like this or something. I don't know. I could even just do this. Then we'd have 1, 1 plus 3. So we'd have 5, 8, 12, 13. So 13 in that case. I don't know why I just typed like that, but yeah, 13. Anyway, you can have 13 characters. Although there is one problem with that, because at the end of the string, there has to be a 0 to end the string. So I'm going to make it 14 characters, actually. Now, whenever I want to define a variable that is a structure, I'd have to say struct record, and let's call it R for record. You have to let the compiler know that you're talking about a structure. And the structure is called record, right here, and we're defining a variable of that type. Now, you can do this and assign all the members of the structure to 0. Or what you could do, at least in C, and maybe in modern C++ now, you can specify the name equals, you know, I don't know, say tepid coder, right? Something like that. You could say, let's see, address equals 123 Fake Street. Okay. And I can say, let's see, phone number equals, I'll do the same thing I did up there. You know, 123 321, you know, 9876, whatever. So that should work. And what I can do here is I can say name. I can say address. Okay, and I can say phone number. Don't know why I only capitalized that one, but that's what my brain wants to do today, so that's what we're doing, I guess. Okay, r dot name, r dot address, and r dot phone number. Now, as you've noticed, you have to access the members inside of this variable. The variables are named whatever I called these: sc name, sc address, sc phone number. And the variable that's stored in is called r. So the way you get at them is r dot whatever these names are. Okay? So let's try that real quick. Let's see if it complains. It likes it, so it's working. Alright, so that's pretty neat. Now I could also have done this. I could have initialized it to some default value, 0. So every character in here would be equal to 0, so when you try and print it, it would just print nothing. So let's try that real quick. It's really good to initialize your variables with 0, if you can speak English. Alright, now what I could have done, what was that all about? Try that again. Could have done this. Assigned them all one at a time. Like that. That is not what I wanted to do. There. Okay. Where did I mess up? Incompatible types. Oh, right. So I defined this as being an array of 20 characters. I can't just assign it like that. What I could do is I could copy the string in. So you can't just assign a string because a string is a memory address. And this isn't a memory address. It is a memory address that holds 20 characters. So you can't just copy like that. You have to actually copy it byte-wise one at a time. This right here is the same as saying, like, a for loop. So for each item in the string I want to copy, for example, let's say, you know, tepid coder is like 5, 6 plus der, 6 and 5 is at 11. Might have miscounted, but it doesn't really matter. I'm just kind of showing. I could say, if I had this inside of a variable, let's do that real quick. Let's say const char star s for string equals that. In fact, I'm going to do this. That way it has a definitive size. I could say, this is even easier because I can do this. Size of s. That's how many bytes this is, and each of these characters are 1 byte, plus a 0 at the end. So for each of those, I'm going to say r.scname, the current position, how many times you've looped. So 0, the start of this array, remember you start at 0, we're not offsetting at all. The very first character, character 0, equals s, its current character. So the 0th character of this equals the 0th character of that. So I'm copying the t into here. Then I copy the e into here, and so on and so forth until I reach the end. I copy the 0 over, and then we've reached the size and we stop. So that right here is what this is doing. Except for this variable is just being defined on the fly and never actually defined anywhere, you know? Probably knows about it, but it's not actually referenceable in the code. Anyway, I'd have to do the same thing for all these. We're going to copy them all. Once I get to C++, this kind of stuff will be way easier, because the language does that stuff for you with its standard library functions. Alright, so I'm going to copy all of these into the structure. Alright. That is not what I wanted to do again. Dang it. Okay, doesn't know string copy, because that function is defined in string.h. There, okay. Now what does it want? Something like 129. Expected. Oh, right there. Add an extra character in the line. Okay, test. There it is. So it still works. So I hope that's explained enough that, or well enough that it makes sense. This can only hold 20 characters. And you can't just assign an array like that. You have to actually copy things in one element at a time. And like if there's a size mismatch, I guess I should show that too. What if I do this? Like char c, call it ccc or something, because I define it somewhere else, equals, let's say there's 3 elements, and I say it equals, 1. I only get 1 element. That will actually work. It's just going to make any values I didn't specify be 0. So watch, I'll compile it. So it's happy with that. But I wonder, what if I do this? Only give it 1 character, plus the 0 terminator at the end. So let's see, do that too. So I guess you can actually define it with less characters than it needs. I'm assuming the last character probably will be a 0 automatically. Let's see if that's true. So I'm going to start at 0 while it's less than size of ccc. Go to the next value. So like it's 1 bigger. It starts at 0 while it's not equal to the number of elements in this, which is 3. Then keep going up. So it'll be 0, it'll loop, 1 it'll go, 2 it'll go. That's all 3. 0, 1, and 2 is 3 items. So when it hits a 3rd, it's actually going to be the 4th item, which I'm not going to do. It's going to break out. So inside this little block of code between here and here, it's a code block here. Every time this statement right here is true, while I is less than the size of this, less than 3 bytes, I can make that even more clear by saying divided by the size of 1 character. Because if this were like a different type that were bigger, the size would actually be bigger in bytes. So if you say the size of this whole thing, CCC, which is 3 times the size of a character, and I divide it by the size of a character, then it's just the number in here, number of elements. But since a character is 1 byte, I mean, this is just dividing by 1. It's the same number anyway. It's just this, which is just this, 3. Anyway, let's see here. Standard out is where I'm going to print. I'm going to say, let's print the value. Let's pretend it's an unsigned 8-bit integer. And let's print out the actual binary value of each of these characters. I'm expecting to see a 1 in ASCII, whatever that value is. I'm going to see a 0, because I have a null terminator at the end of the string here. And then probably another 0, just because I didn't fill it with anything. That is my guess. So let's see. CCC position I. So the value I'm presenting is going to be an unsigned 8-bit integer, and I'm getting that integer from the ith element of the variable ccc. So first it'll be the 0th element, which is this 1, whatever that is in ASCII. Let's find out. Character map. Type. Character map. Come on, come on. Okay, here we go. So I need, where's the value 1? Right here. So it's going to be 0x31 in hex. In fact, I can actually print this out as a hex value. Why don't I do that? 02x. So it's going to be padded to at least 2 characters, 2 digits. So if it's like the value 1, it would be 01. That'll make it a lot easier to see. So we'll see if that number was the same. Okay. So we got 31, 0, and 0. I don't remember, I forgot. Was that the right number? Yeah, 31 in hex. So yeah, that is what happened. So I guess if you define a string, or any kind of array, and you don't fill the entire array, whether you're defining like a string like this, or if you're doing an array and defining it like, what do I say, like this, it'd be 1, 0, 0. Either way, if you don't define that last element, it's just going to put a 0 there anyway. See? Same thing, 0 here. So I wasn't sure about that, but I kind of suspected that was the case. Anyway, when you have records like this, usually it's common in C to create an initialization function. So instead of having to type all of this junk, what you would do is you put that into a function. And you'd say something like initialize record. And you're going to say R, the record you want to initialize, and you're going to give it some values to put in there. So I'm going to do that real quick. Let's say void. It's not going to return anything. Initialize record. I'm going to say record R. Now this isn't going to work. I'm going to show why in a second. So I'm going to grab all these. Let's grab this, paste. We'll grab this, paste. Grab that, paste. Okay, let's put this down here somewhere. Come on. Okay. I need to put commas here. Alright. So, when you pass something to a function, in this case, I'm passing a record structure. I have to put struct record. It passes it by a copy. And I'm going to show you exactly what that implies by filling the structure, and I'm going to print the values inside the structure here, and you'll see they change, but then I'm going to print them out here as well, and they're not going to be changed again, because it's a different instance of that structure. So you'll see in a second. I'm going to do a constant character string. So this pointer means I'm referencing wherever in memory the string is. Constant means I'm not going to change any of these characters in the string. I'm going to leave it alone. But I can change where this points if I wanted to. So I'm going to say LPSC name. LP being long pointer, and SZ being string 0, meaning it's terminated with a 0 at the end. That happens automatically because it comes with these little quotations inside C or C++. Okay, so LPSC redoing address. Const char star LPSC phone number. So what I'm going to do here is I'm going to copy from LPSC phone number. Let's get that over here. LPSC address. LPSC name. Okay, so I am calling initialize record down here, and then I'm printing it out. I'm printing it out down here, and I'm also printing it out over here. Now, the first time I print it out, everything's going to be correct. The second time, it's just going to be empty strings. You'll see empty quotes. Let's see, the first time it worked, second time it didn't. And that's because I copied the structure into the function. So this record I have right here, where is it? The record I defined right here is initialized with 0. Okay, this structure gets copied, which has nothing in it, it's just a 0, into the initialization function. And I tell it to assign these values to the copy. So this now has a copy of that record. It copies all of these strings I told it to into that structure to prepare it, and then it prints it out. But once that function's done, I print out the value of this record, not the copy right here. So this one was only assigned to the value 0, so everything is just null. It's not initialized. So that's why nothing happened. If I want to actually pass it the real variable that I'm working with in the function, I pass it by reference. So I'm saying this right here, ampersand, means I'm referencing the variable that's passed to it. So I'm passing this right here, which comes from this. That's where I'm defining it. I'm passing the address of this in memory. And it's going to modify that because I use an ampersand. So the type at this point is this. Like this whole thing right here is the type. It is a structure called record, and it is a reference to one of those. Alright, so we'll run it now, and both times it's going to print the correct information. See? Now, the way I showed you just now, with that ampersand, is actually a C++ specific thing. You can't do that in C. In C, you would have to use a star, which you're saying there's a pointer. So the type is record pointer. It is a structure record pointer. So if you actually want to pass it the reference in memory, or the address in memory, what you'd have to do is you'd say, pass the address of this variable. That's how you do it. So when you say ampersand in front of a variable, you're saying the address of this variable. That's what I'm passing, wherever this is in memory. And I can show you that and prove it. So watch this. Check this out. So if there's a thing called since p, which prints out a pointer. So I'm going to say, what the heck, man, I can't type in. Record location in memory is going to be this address. And what I'm going to do is the location of R. And now what I'm going to do is I'm going to do the same thing inside here. I'm going to show the address that it was passed, right? So in this case, R is actually a pointer. So what I typically do there is I'd say LP underscore for long pointer 2, and then it's a record, right? And I'll do that. I'm going to say long pointer record. And so every instance I have of search for R space dot. Okay. We're going to replace that with dot. Okay. Yes, yes, yes. Yes, yes, yes. And no. No, no. Okay, we're done. Alright, so I'm going to print the address in memory that was passed to us. It's the address of this record. And that should be the same as the address that I printed out right here. And just so you know, this is coming from the function as well. What I like to do sometimes when I'm debugging is I'll put in brackets like the name of the function, which is initialize record. There's a different way I can do that. I could also just do this, sign S, and then there's a preprocessor macro I could use called function. And that's just going to be replaced with a string named after the function. Right? It might have the actual full qualification, like all of this data too, but it might also be this. Depends on the compiler. And also, I forgot a comma. There we go. Okay. Let's try and... Ooh, didn't like that. Oh, right, that's the other thing too. I forgot to mention that. So, C++ makes this easier. When you use this ampersand, you can act like it's the same structure as it was defined, like it's locally scoped. If you use an asterisk, you actually have to dereference the asterisk. You have to treat it like a pointer. So basically all that means is that if you pass it with a star like this, you have to use an arrow operator to access the members of the structure, these things, instead of a dot. If you pass it with an ampersand, you can use a dot. So C has to do it this way, and you have to use the arrow operator. So, silly me. Did not mean to do that. Come on. So what's it have you got now? Unless I forgot an arrow somewhere. 43. Yep, right here. When I'm printing it out, I also needed the arrow operator. I don't even really need this anymore because I already showed how it works, but that's okay. Okay, you can see it works again. So that does the same thing, and this is the C way of doing it. And also you can see these addresses are the same. That's the address in memory where it is. And it probably should change every time I run the program, see? Because you get a different slice of RAM every time you run your program. You have no control over that. So you can see it's changing every time. What else can I say? Right, so I talked about arrays earlier. I want to make an array of records this time. So let's get rid of this code. I'll leave it in there, why not? I might post these code snippets to GitHub or something later, just so people can play with them if they want. Yeah, let's make an array of these records. So the way you do that, the type is struct record, R is the name. I'm going to say I want 2 of them. I'll initialize them both to 0. And what I'm going to do now is I'm going to say initialize record. I'm going to give it 2 records. So let's call it that guy. He lives on 124 Fake Street next door to me. And his number is 123 4321. All right. Now what I want to do this time is I'm going to say, how about for size t I 0 sti less than size of r, which really at this point I would say like array records or something like that. It's array of records divided by size of struct record. Plus. When you're working with the length of strings, or you're working with array indices, really you should be using a size t data type. And the size t is basically just the size of the maximum unsigned integer you can use for the current architecture. So if I'm compiling for x64 architecture, it's 64-bit. So this really is just going to be this. So if I wanted to, I could just say uint64t. I prefer just to use size t because it's standard there. I know I didn't mention this in the primitive type videos, but I knew I would get to it later in a place where it made more sense. And this is that time, so I'm kind of a stickler for how I format things. I've been trying to be a bit more lazy about it, but my OCD is getting the best of me right now. Okay, anyway, I'm going to print out each of the structures. And I'm going to do this in another function. I'm going to say show structure, or show record. And struct record. In fact, I'm not going to modify the structure, I'm just going to show it, so it's const. I'm promising that I'm not going to modify it, and I want to pass it by reference, not a copy. When you copy the whole structure, it's really slow because it pushes the entire thing on the stack. Maybe I'll have to make a video about stack segments and how that works later. It'll take me a second to prepare a video for that, but you'll be able to see pretty quickly why it's slow to push things onto a stack and like make copies of everything, especially of class objects. Passing by reference is almost always faster. Anyway, I'm going to pass it by reference using the ampersand instead of doing it the C way with an asterisk, just so I can keep using these dots. What else? Right, okay, I'm going to show the record. And instead of, doing that whole fprintf thing every time, I'm just going to do this. Show record, sti, which is the current record index, from 0 up to the number of elements. And the way I defined it, I can just keep adding more and more if I wanted. So let's try and compile that, see if I didn't make any mistakes, or if I did. Okay. So, looks like I made a mistake on line 87. Cannot convert record to record pointer. Oh. I think I see why, yeah. So, here's something else I didn't mention. And it's good I made this example because of that. So, if you define something as an array, it doesn't matter what the type is, but if you have an array of it, as soon as you mention the variable itself, it treats it like it's a pointer. So, struct record, 2, you could look at it as being that, right? But really, it treats it like this, struct record pointer. It decays into that. That's how the compiler treats it. So when I'm passing it to a function, all I really have to pass is r, because r is this type when I'm passing it. But I could also do this. I could say that, I'm only ever passing that, right? That'll work the same. In fact, I'll do it here. Over here, I'm going to do it a little bit differently. I'm actually going to use the pointer version I was showing earlier, which means I have to use the arrow operator. Okay, and then down here, R for both, it's actually going to be struct record pointer, right? And it's actually going to become const struct record pointer, just because it takes const. It'll automatically convert that for me. Okay, and 101, what does it care about? It does not like array record, because I never renamed it. Right, okay. Record, array, record, whatever, records. In fact, I could just call it record, whatever, I'm going to leave it like this. Doesn't matter. No. Okay. Okay. Yes. Okay. One more error over here, 104. Cannot convert record to const record. Oh. Right. Okay. So in this case, when you access an element of an array, it becomes the element type. So like if you have, I don't know, some type t, and you have an array of those, and you pass it to a function, what you're really getting is a t star, right? And if it takes a const t star, then that's what you're going to get. But if I actually pass t position something, like 0, it's going to give me a t type. That's what it's passing. And if I ask for a const t, it'll give me that. Not a const t asterisk. So in the function, if you notice what I did up here, is I told it that I wanted a pointer to a record. So if I want a pointer to a record, I have to say, well, what is the location in memory? Like this. Location of this index of this array. So that should work now, I think. It does. And now it's happy. So I printed both out. We have name type encoder, 123 fake street, you have the number. And now we have that guy, 124 fake street, some other number, right? And each of these is getting printed twice. That's because the function itself is printing it out. So I'm actually gonna kill this one, we don't need it. Okay. And I'll put this above, just in case someone else wants to play with this later. If I post it somewhere, they can show the record as a function call right in here, you know. What would it be? Just R, is that what I called it? What did I call it? Oh, it's LP record, that's LP record. And this is taking it as a struct record. This is mutable, but it's becoming, right, yeah. It'll become const. But I have to pass that specific record. Yeah. So let's do something here. I'm going to say position 1 is what I want to pass. Because before I was just modifying the first element both times. I could do this, or I could also just do this, right? Like I said, it already decays into a record pointer, and it's already pointing to the first element, or the 0th element. This is if I want element 1, which is the second element. Okay. Anyway, I was showing you that you could pass an array of exactly 2 items, which only works because I defined it with exactly 2 items right here. But if I want an arbitrary number of items, I can also just do this, right? That's totally fine. And I pass the specific record structure instance that I want. So that's what I'm doing here. I'm passing the 0th element, is what it starts with, and I'm passing the first element. So I'm going to reference both those structures and fill them both. Okay, there you can see the 2 that I referenced. Okay, both of them are filled. Yeah, I only did this once. Right, so something I want to say about this too. You'll notice this address is different. That's because it's moving forward in memory by the size of 1 record structure. And the size of 1 record structure, let's actually show that. So, I'm going to say size of 1 record structure. Okay. Record. Struct record. Okay. So, to do that, I'm going to cast just to be sure I have the right type. So it's 134 bytes. Now, is 86 in hex the same as 134? It should be. So, let's see this. Okay, 134 is 86 in hex. So, there you have it. The first time we pass a reference to one of those record structures in memory, it passes the 0th element, which is right here. That's where the array starts, the array of records. The second element is right here, which is the size of 1 record farther. And this is actually kind of interesting. What I'm actually doing here is I'm saying the location in memory of this second element and the first element. So I get 0, and then I'm going to 1, and so forth. So another thing I could do is I could say struct record pointer. I could say, you know, LP record equals array records. Right, that'll work. I could also say, you know, it's pointing to the position in memory of the first element, right? That's also true. Some people like to do that way, but if I'm referencing the first one anyway, I'm just going to do this. And I'm not going to modify it, so I'll call it constant. So the other thing I could do is this. I'm going to say show record, yeah, and then the pointer to a record. And then what I'm going to say is LP record plus plus. So what this is saying is I'm going to increment this pointer variable, it's record pointer type, to the next record element in memory. So I print the first record out, and I move to the position in memory of the second record, and I print that out. So just to show how that looks, current record location, %sign P to show the pointer in memory, LP record. So before I print every record, I'm going to say where it is in memory. And that should line up with what you see over here and here, except these are going to be different values each time. Okay. So I got a D0. You move forward 1, 3, 4. Goes from D0 to 5, 6. Over here we have D0, we have 5, 6. So this number right here should be the same as this number right here. And this number right here should be the same as this number right here. So that's a lot to cover just now. I'm trying to think if there's any easier way I can mention any of these things. Perhaps I can give a small overview. So if you have any type and you pass the type to a function, like in this case it's an array type, it's going to pass it as the underlying type that you're making an array of, star. So char star is what that is. If I pass this to a structure, or a function I mean. So if I have a function, let's say void foo, some function called foo, so it's, some pointer to a character, right? What I could pass it is some instances record. Like if I have struct record r, I could pass to this function r.scName, right? Because this is a char 20, which is an array, char 20 becomes char star. And this takes char star, so that'll work. So that's thing one. The other thing is, when you reference an array, the arrays start at 0. So if I have scName, it's actually going to have elements, indices 0 through 19. That's 20 items. This will be 0 through 99. This one will be 0 through 13. So that's something to keep in mind. The other thing was, if you pass with a star, a structure with a star that is, instead of an ampersand, you have to use the arrow operator to access the members. And if you pass it with the ampersand, you would have to use dots instead. So that'll work just the same. It should. What did I mess up? 1, 3. Const record from const record star. Validation reference. Oh, I see. I'm going to dereference it. So I'm glad that came up actually. So right here I have a pointer. If I want it to be the actual type, all I have to do is say this. That's the actual value it points to. It's at dereference. The star here means dereference it. That's the actual element. This is the location where it exists. That's the element. That's the difference. So because I have this being a record pointer here, I'm dereferencing it and saying pass the actual element. Okay, that'll work. And this is a bit funny because this expects you to pass a reference, but the way you're actually typing it when you're passing it is as though it were a value. So it's kind of funny. It's expecting it to be passed like it's a value, but then automatically reference it for you based on the function definition. But over here I have a pointer instead of a value. So instead of referencing it, I'm dereferencing a pointer to give it a value that it's then going to turn back into a pointer. So that's a bit silly. And for that reason, I sometimes don't like C++, the way it does this. It is kind of convenient not to have to type the arrow operator everywhere, but I'm really on the fence on how much I like that. I'll probably get into some more reasons about that why. Like, trying to think here. Why it's sometimes confusing if a value is going to be manipulated by a function or if it's going to be only read. You can give some, what do I say, guarantees by flagging things as const, but it's never, what do I say? It's never completely clear what you're intending to do when you pass something by a reference. Like, for example, sometimes a function wants to output more than one value, and so you'll do that by outputting to a pointer to some variable that you accept to the function. You don't read from it, but you do write to it. And I'll show later how I deal with cases like that to make it more clear. Anyway, for now, I'm going to use this in the more traditional C way, because I think it's a bit confusing to look at it that way, and have something that automatically converts into a reference based on the function definition and declaration, instead of something that you explicitly pass as a reference. Anyway, I'll leave it like that. That's going to work. So we talked about array types decaying into their underlying type as a pointer. We talked about arrays being 0 based, so 0 to the number of elements minus 1 is what you can index. We talked about how to pass things by reference in C and C++, what kind of operators to use depending on how you pass it. Talked about how to dereference something. And we talked about how to manipulate values and reference specific values using the, what do I say, subscript operator, these brackets. So the only other thing I think I really want to talk about here is how to use a pointer a little bit differently. So if I have, let's do this. I'm going to say a character array. I'm going to call this SE string. I'm going to give it 5 characters. It's going to be, I don't know, test. But what comes before T? A, B, C, D, D. S comes before T, right? D comes before E. What comes before S? R. And then S. So I want this to become test. In order to do that, I'm going to say char pointer P. I'll put this in a new scope just in case I've already used these variable names. Equals SE string. Now I'm going to say while dereference P, which remember, if I dereference it, currently P points to the 0th character of the string, right? Now if I dereference it, what is the 0th character of the string? It is a type character. So I'm going to get this character right here, S. So while this is not 0, well, when's it going to become 0? Equals 0. I'll make it explicit. If you do if or while or for, and you don't specify like not equal something, it's always just testing to see if it's not equal to 0, but I'm just going to write that out so it's obvious. So every time I loop through, if it's not 0, it's going to continue, and I'm going to go to the next character in the string. So while I'm on this character, I'm going to say the value at P plus plus. So whatever this value is going to increment. So it was S, it's going to become T. D is going to become E. R is going to become what, S, and then S is going to become T. So it's going to be test. Okay, let's actually print this out so you can see it. Sign S. I'll put it in quotes so you can tell there's no garbage after it. SE string. And there it is, test. I could have also done this. This might be more clear to you. Like if I say, I don't know, P position 0 equals or plus plus, right? That means the same thing. So you can do that if it's more comfortable to always just use the brackets to index things. For me, a lot of the time I find it's easier to just do, you know, like star T equals 10 or X, right? If I do that, everything's just going to become X's, before X's. Sometimes it's just easier, so it's good to know that syntax if you reference something. So I'll leave both these in here and use this one. Anything else I haven't mentioned about pointers? You can index into them from 0 up to 4, because it's -1. I talked about how to pass by reference. Remember, I could also do this. You can reference the location memory of the 0th element. It's the same thing. I feel like I'm missing something, but I don't think I am. What I'm going to do, I think, is review this video. I will post it as it is, but if I feel like I've missed something, I will do a follow-up on this video. But for now, I think this is going to be it on structures and pointers. Alright, have a good one.